Today we're going to start talking about chemical reactions and how to write the equations for those reactions. And in your book, he talks about a reaction where he's combining methane with oxygen. And so at my house, I've raised lots of boys, and when you have lots of boys, you have lots of blocks. So I'm going to actually use blocks to represent these different molecules that are in this reaction. In the blocks that I'm using, the green represents carbon, the red represents oxygen, and the blue represents hydrogen. So on the left side of the equation, we start with a CH4 molecule, and this is in your book. And so a CH4 has one carbon and it has four hydrogens attached. You can see one green block and four blue ones. That can be burned as a fuel, and then when you combine it with oxygen, because that's always required for burning, you'll recall that oxygen is a diatomic element, and so you're never going to have just one single atom of oxygen. They always show up in pairs, so that's why I have two red ones hooked together. So there's an oxygen molecule, and when those two go together, they combine to form, and that's what this arrow means. It means to yield or to make. They make a carbon dioxide, and so I have a carbon combined with two red ones, two oxygens, so there's carbon dioxide, and then this is supposed to represent a water molecule where I have an oxygen and two hydrogens on the top. Now, if you look at this, you're going to notice that there is a problem, because how many red ones do I have over here? Well, on this side, I only have two. On this side, I have three. That doesn't work. I have one green one on each side, but my blue ones aren't the same on each side either. I've got four blue ones on this side, and I only have two blue ones on this side. And what's always true is that the law of conservation of matter is going to hold. You can't destroy it, you can't create it, so whatever I start with, I have to end up with. So for starters, I don't have enough oxygen to start with, because I know I had to end up with three over here. So if I bring in another oxygen, I now am going to have two molecules of oxygen, and that made almost a bigger mess, because now I've got four oxygen atoms on this side, and I still only have three. So what I need to do now is I'm going to bring in another water on this side, and when I do that, I now have one green one carbon on each side. I have four blue ones, and I have four blue ones on this side, and then I have four red ones, four oxygens on this side, and I have four red ones on this side. So you can see now that everything is balanced, because on this arrow, it almost acts like an equal sign, and what's on one side has to be the same as what's on the other side. So now we're going to put this into the form of a chemical equation. So excuse me while I move the camera and get it up here so that you can see my board. Okay, so that is why you see these symbols looking the way that they do. Here's your one carbon and your four hydrogens that are all hooked together. This is what we used to represent that. And the two oxygens, O2, means that they always come hooked together, and I needed to use two of them to make one carbon dioxide and then two waters. Carbon dioxide has one carbon, two oxygens. Water has two hydrogens, one oxygen, and I needed two of them. So here's what you kind of need to keep in mind. The numbers that are on the bottom are called subscripts, and they tell you how many atoms that you have to put together to make a specific molecule. The numbers that are in front are called coefficients, and that's not a word that he uses in the book, but it's one that you need to know. It's probably one that you recognize from algebra. If you put a 2 in front of an x, the 2 is called a coefficient. It's the same thing in chemistry. This is called a coefficient, and so it tells me that I need two oxygen molecules. So let's make sure that we've got our terminology straight. I'm going to go up here and I'm going to circle all of my subscripts in green. So the 4 is a subscript, the 2 is a subscript, this 2 is a subscript, and this 2 is a subscript, okay? Then I'm going to mark all of the coefficients. I'm going to circle all of those in blue. So this 2 is a coefficient, and that too is a coefficient. Okay, that tells me how many of each kind of molecule that I have. There are also letters after each one of these, and that tells me what phase it is in. So CH4 or methane is going to be in the gaseous phase. Oxygen is a gas, and when this combusts or burns, it also makes gaseous carbon dioxide and gaseous water. And so we're going to mark the phase symbols in red. So this, and this. Those are our phase symbols, okay? Now you will, obviously in this equation, they're all G's for gas. An S will stand for solid, an L will stand for liquid, and sometimes you will also see an AQ. That stands for aqueous, and what that means is that you've got a solid that's been dissolved in water. So if you take salt and dissolve it in water, then you'll see the symbol for salt with an AQ after it to indicate that you have a solution of salt dissolved in water. And that's what that means, okay? Now, what is on the left side are classified as reactants. That's what reacts together. On the right side, it's classified as products. So if you're asked what the reactants are in a certain equation, you're going to look at whatever's on the left side of the arrow. The reactants are CH4 and O2. Now, when you're asked what the reactants are, you don't want to put the coefficient in front of it. You only want the formula for the particular molecule that you're dealing with, for the compound that you're dealing with. The products are always on the right-hand side of the equation. And so here, our products are CO2 and H2O. Okay? Now, I had told you in your lesson plans that you should have the sheet for sample problems for video number 4 and number 5 with you when you were watching this video. So now's the time when you want to pull that out. And if you look at the very first equation on there, that's what this equation right here is. What I would like for you to do is I want you to pause the video for just a second, and I want you to answer all those same questions that we just answered for this. So pause the video. If you have colored pencils or markers, you can kind of mark those in the appropriate colors. And then when you're finished with that, turn the video back on and we'll go through and we'll mark them all. Okay? So hopefully you've marked all of them now. If you mark your coefficients in blue, you're going to have this 2 and this 2 and this 2. If you mark your subscripts in green, there aren't any subscripts in this one. They're ones, but we don't actually write them there. So you're going to have a 2 here, and you're going to have a 2 here for your subscripts. And then for your phases, here's the AQ that I told you about before. That's aqueous. That means that we've got hydrogen monochloride dissolved in water. So this one is aqueous. This one is solid. This one is aqueous. And this one is solid. Okay? Then the last question there asks if it is balanced or not. And in order to do that, you're going to have to look at each particular type of atom on each side of the equation and do some counting and see if it's actually accurate. So on this side, all of my hydrogen is contained right here. I don't have any subscripts, so for each molecule of hydrogen monochloride, there's just one hydrogen, but I have 2 molecules of it. So that means I have a total of 2 hydrogens on this side. Over here, you'll notice that this looks very, very similar. There's only 1 hydrogen in a molecule of hydrogen monobromide, and there's a 2 in front of it, so that means I have a total of 2 hydrogens, okay? Very similarly, I have a chlorine, has a subscript of 1, but there's a 2 in front of it, so I have a total of 2 chlorines. On this side, I have a 2 for the chlorines here, but there's a 2 in front of it, so that means that I have a total of 4 chlorines on this side. Well, that is not the same number that I had on the left, because I've got 2 chlorines here, but I have 2 times 2, which is 4 over here. So the answer to that last question, is this equation balanced? The answer is no, it is not balanced. Okay? So what we're going to do now is we have 4 more equations, and we're going to check and see if they're balanced or not. So this one was no, it is not balanced. So we'll do this one together, and then I'm going to let you try the other three yourself. We're going to start with the carbon in this next equation. I have 6 carbons here. Remember, there's a subscript of a 1, so 6 times 1 is 6. And on this side, I have 6 carbons here, and there's a 1 in front of here, so I have 6 carbons on both sides. The oxygen, you're going to have to be careful because it appears in 2 different spots. So here I have 6 times 2, which is 12. And here I have 6, and there's a 1 down here, so I have 6 here. So 12 plus 6 makes 18. On this side, there's a 1 in front of here, so I have 6 oxygens in this compound. And I have 6 times 2 is 12. So that's 12 plus 6 is 18. I have 18 on the left, 18 on the right, so the oxygens are balanced. I still need to check the hydrogen. I have 6 times 2 is 12 hydrogens here, and then I have 12 hydrogens on this side, so I have the same number on both sides. So yes, this equation is balanced. Now, I want you to pause the video. I want you to try the next 3 by yourself and see if you can figure out on your own if they're balanced. Then I want you to come back and we'll do them together, okay? All right, so if I check this first equation here, carbons, I have 2 times 2 is 4, and I have 4 here, so the carbons are balanced. If I check my hydrogen, I have 2 times 6 is 12 hydrogen, and I have 6 times 2 is 12 hydrogen over here. When I check the oxygen, I have 7 times 2 is 14. On this side, I have 4 times 2 is 8 in the carbon dioxide, and I have 6 more in the water. 8 plus 6 is 14, so I have 14 on both sides. So yes, this equation is balanced. Okay, how did you do on the next one? If I check the nitrogen, nitrogen comes what I have first here, so I have 6 nitrogens on this side. I have 3 times 2 is 6 nitrogens on this side, so the nitrogens are balanced. How about the hydrogen? 6 times 4 makes 24. And if I look over here, here's my hydrogen. 3 times 8 also makes 24. So the hydrogen is balanced. If I look at the aluminum, I have 2 here. I only have 1 over here. So this equation is not balanced because I don't have the same number of aluminums on both sides. So this one is no. This equation is not balanced. And then we'll check this last one here. Calcium, I have 1 on this side and 1 on that side, so that's okay. If I look at the fluorines, I have 2 here, but I only have 1 on this side. So the fluorines are not balanced, so the answer here is no. Now, as you can see, once you find one atom that isn't balanced, you can stop, because if one's not balanced, then the whole equation isn't going to work right. So you're going to have some practice to do these on your own. If you have any trouble with that, make sure you ask me, because you need to make sure you have this part down before we start balancing them yourself tomorrow.